In the last video, we were talking about force in something called free body diagrams. And we said a free body diagram was designed to show us all the forces that are acting on an object. So if I took some object like some box, let's say I've got a box here. All right, and the box is sitting on the ground. I have, of course, the force of gravity that's going to act on the box. Let's say force of gravity is pulling downward on the box, and that is called its weight. Did I spell that right? I think so. So weight is simply the force of gravity on an object, and it's equal to the pull on the object due to gravity here. So, of course, gravity is pulling down on the object, and the Earth is going to push upward on the object. So that's the force, let's say, the force of the Earth on the object. And sometimes we call that the normal force. N for normal because it's perpendicular to the surface here. So that would be the forces acting on the body, and we draw the free body diagram like that. Similarly, if we had, let's say we had a car, or let's say a sled. Here's the ground, let's say that's the snow, and we're going to make ourselves, let's make ourselves a sled here. Here's the sled in red. There's our sled, toboggan style. And let's say we've got a rope that way, and somebody's pulling on the sled. So there's the force of the rope on the sled. Then of course we have the force of gravity on the sled, and then we have the force upward, straight upward, of the ground, which we're going to call the normal force. So that would be the forces acting on the sled. This is how to draw a free body diagram. Another example, let's say you have a table. Here's our table, and we got a physics book on top of the table. What forces are acting on the book? Well, we have gravity, so there's our force of gravity acting downward. And then, of course, we have the normal force of the table acting upward on the book. Now today what we're going to talk about is something called the net force. Net force. And the net force is equal to the summation. This is the summation symbol of all the forces. All forces acting on the body. On the body. Or the object. So let's take an example. If I have, let's just say we had a box over here, and it weighs, let's say the box weighs 20 newtons. So we have the force. Let's draw the free body diagram first. We have the force of gravity is 20 newtons downward. Now we have the force of the earth pushing upward, or the floor that the box is sitting on pushes up on the box. And that's the normal force. Now we don't know what that normal force is, but the box isn't moving, is it? So the normal force would have to be 20 newtons upward. In other words, if gravity's pushing the box down at 20 newtons and the floor is pushing the box up at 20 newtons, they kind of cancel each other out. So the net force here, the net force is the summation of all the forces. So what is the forces? The sum of all the forces. Right? So what's the forces? Well, we have plus 20 newtons from the normal force, and then we have a minus 20 newtons, because this is the force of gravity pulling downward. So if we assume that up is the plus direction, we have minus 20. So plus 20 and a minus 20 is going to give us 0. So our net force in this case is 0. because the two forces cancel each other out. Let's try another one. Suppose I have a box like this, and it's on the ground, let's say, and let's just say there's no friction here whatsoever on the ground, but I have a rope tied around it, and I'm going to pull in this direction with a force of 20 newtons, and let's say someone else is on the opposite side and they're pulling this direction with 15 Newton force. So what's the net force in this case? What is the net force? The net force on the box is the summation of all the forces. And what is that? Well, we have a minus 20, because this 20 is going in the negative direction, negative x direction, and then we have a plus 15 going in the positive x direction. And when we add those two together, we're going to come up with a minus 5. So our net force in this case is minus 5 newtons, or 5 newtons in that direction. Let's try another example. Let's say we got a box here. It's attached to a rope, and the rope is going around a pulley, and somebody over here is holding on to the pulley, our stick guy here, holding on to the pulley with both hands and pulling upward on the box. Let's say that the box weighs 20 newtons. So the force of gravity, then, let's draw a free body diagram. Look at all the forces that are acting on the box. What forces are on the box? So we want forces acting on the box. What are they? Well, first we got the force of gravity. That's pulling the box down. Then we got the force of the rope pulling the box up. So now let's give some numbers here. Let's say, what do we say, 20? Let's say the force of gravity is 20 newtons, and I'm going to be pulling up, if this is me, I'm going to be pulling up with a force of 30 newtons. If that's the case, what's my net force? The net force, then, acting on that box, is again the sum of all the forces acting on the box. And what are all the forces acting on the box? Well, I got a plus 30 upward, and then I got a minus 20 down. And if I take plus 30 and a minus 20, I come up with a plus 10. So the net force in this case is going to be equal to 10 newtons upward. And that's how you calculate the net force.